My name is Lewis. I'm here doing an informal test on SuperHydro to determine what kind of efficiency that we have. So we're going to go ahead and hook it up. I've already got everything hooked up. We have a gallon of distilled water in here, and we have 2 ounces of KOH, potassium hydroxide. So I'm going to check the wires. I'm using a gasometer here, and it's a tennis ball can with a 1.5 inch radius. Okay, we're connected. Get the timer here. Oh, wait a minute. I gotta set the amp gauge. Hang on. Got a digital amp meter here, and I also have a Fluke multimeter for testing voltage. This is a clamp on, and it measures DC amps. I'm going to zero it. Okay, it's zeroed. We're hooked up. Start the timer. We got an open circuit voltage, if you want to come over and look at this, at about 12.69 volts, if you can see that. The amperage that we're drawing is around 8.1, 8.2, if you can see that. Okay, we're going to run just a 30-second test. It looks like we've got just a few more seconds to go here. There we go. It's 30 seconds. So, try to figure out what kind of a rise we got on this thing. It looks like we got around, it looks like 2 3/8. So 2 3/8 inches. Let's do a little math. What was it? 8.2 amps, right? 8.2 amps, and the voltage was what? I forgot. Open circuit voltage was about 12.7. Okay. So 8.2 amps times 12.7 volts. That's 104 watts that we were drawing. That's how much power we had, 104 watts. We got a 2 3/8 rise. I know from doing this math previously that in 1 minute that would be 44.76 cubic inches of gas. If you convert that to liters, you've got 0.773 liters. So 0.773 times 1,000, that would be 773 milliliters of gas. Okay, divide that by 104 watts, and it looks like we hit a 7.43 MMW, which is milliliters per minute per watt. 7.43, which is pretty high. And just to clarify the test, this battery that we're using does not have a battery charger hooked up to it, so we've got straight DC current, which is more reliable when you take your readings, especially from one of these digital clamp-ons. If you have a battery charger hooked up to this thing, it's going to skew your readings because the battery charger is going to pulse your DC just a little bit. If you put an oscilloscope on there, you'll find out the electricity is a little bit dirty. It's not level and smooth like you'd get from a battery. So this is just pure battery power. We use a good multimeter and a good clamp-on gauge to measure the DC amps. So as far as I can tell, this 7.43 is as accurate as I can get it with with what I have available to use. Again, it was 1 gallon of distilled water and 2 ounces of KOH, which I had right here. 2 ounces, which I measured with my $30 scale. And that concludes the test for SuperHydro. Thanks. Actually, I'm double checking my math, and the volume being 733.6 milliliters divided by the 104 watts that we used is actually a 7.05 MMW. So I made a mistake in the division, but what it should be is 7.05 MMW. That should be the rating. Still a pretty good rating, and I just wanted to clarify that little minor error there. Anyway, this test was run, right around 12.6, 12.7 volts, and normally an engine in a car with the engine running, the alternator is producing some current. and some voltage to charge the battery, normally you're running about 14 to 14.5 volts. And in that kind of situation, the gas output is going to be much higher. As a matter of fact, on one of the tests that we ran, we had the voltage at 13.87 by putting a battery charger on the battery, and it put out 2.16 liters a minute. So it's easy to get quite a bit of production on a SuperHydro because normally your engine is running at a higher voltage, and also by just making the KOH mixture a little stronger, you could easily take it over 3 liters a minute. Wouldn't be a problem. Alright, again, thanks for watching.